Greetings, math fans. All right, so this next topic is called angle of elevation and depression. Really don't like talking about this topic because I don't mind the elevation, but the depression is just so sad. Okay, if I could rename this topic, it would be called angle of elevation and happiness, and then everyone's happy and there's no crying. All right, so the main thing with this topic, math fans, is you always draw from the horizontal line. I cannot stress that enough. Okay, I'm going to highlight this. Always draw from the horizontal line. That is so critical, right? So let me just really quickly explain this. Here's the horizontal line, and this is the angle of elevation. So it goes up because it's elevating, you go up. And then angle of depression is always, again, from the horizontal line going down. So it's angle of depression. Okay, but always from the horizontal line. Again, I cannot stress that enough. That's probably the number one mistake. Is I see kids when I say angle of depression, sometimes they go from this distance, this angle right there. This is so wrong. I'm going to put a red X through this. Okay, don't do that. All right. All right. So let me just give you an example here. If I told you the angle of depression from the top of a building to log E, which is a little log sitting down at the bottom of on the ground someplace, that angle of depression is 30 degrees. And the height of the building is 100 meters. The question is find the distance from log E to the base of the building. So this is the deal. Here's your building, and I would always recommend whenever you draw a building, don't draw like a fancy building with, two-dimensional everything. Just draw a line, a vertical line. That represents a building. And then if I told you that the angle of depression from the top of the building to log E, so what you're going to do is you're going to draw a dotted line. And this is the angle of depression going down. So this is, again, I'll just draw a little thicker. So this is our building. And this is, on the ground here, this is log E. So we're going to draw a log. Okay? And angle of depression, if I said it was 30 degrees, it's this angle right here. Okay, not this angle. It's the number one mistake. It happens every single year where kids, I get a couple kids that they just don't listen. And they just draw it from, the vertical line. Okay? This is so wrong. Don't do this. Don't do that. Okay? So, let me actually erase that. Okay, so we have that 30 degrees, and again, whenever, I want to mention this again, whenever you're drawing a building or mountains or anything that's like has a height, just always draw a vertical line. Like a tree, don't draw a tree, just draw a vertical line, okay? So anyway, the kids kind of get this confused too. If I say find the distance from log E to the base of the building, guys, the base of the building is in the bottom here. That's the base, not the top. That's the top. The top is the height. So really, here's your triangle. Here's your right angle, and I want to find this distance x. Okay. Now, what can you do with that 30 degrees? Well, I could, if I wanted, I could make, since this is 90 degrees here, I could put this angle inside the triangle and make that 90 minus 30, which is 60. Okay. It's okay to do that. So, but I'm going to erase this. Okay, what I would rather do is you to understand if that's 30 degrees, this is also 30 degrees. And why is that the case? Because what can you tell me about this angle and this angle? Well, first of all, this line right here and this line right here, aren't they parallel lines? Because again, they're both horizontal lines. And if you have a line going between those, the transversal, what can you tell me about these two red angles? Well, they are alternate interior angles. And what can you tell me about alternate interior angles? They're congruent. This is kind of nice. Again, you could say that angle on top there is 60, which would be just as fine. But I think knowing that these angles are alternate interior angles and they're congruent, it's perfect. Because now I can transfer the 30 degrees inside this triangle. Okay, and I didn't mark this yet, but this is 100 degrees or 100 meters high. So all you need is one angle on one side, guys. And then when I'm looking for x, it's easy. So remember, what trig function am I going to use? Well, I have this right here, and I'm looking for x, and I have this angle right here. So which one uses, this doesn't use hypotenuse here. So I'm using opposite, and I'm using adjacent. So I'm going to be using tangent. So tangent of 30 degrees equals opposite 100 over adjacent over x. That's it. Okay, and I cross multiply, I get x tangent 30 equals 100 divided by tangent 30. So 100 divided by tangent of 30 is 173.2 meters. Okay, so that's how you do that problem. But remember, from a horizontal line. All right, and then the second problem that I have here, let's clear this out of here, is basically I have two buildings. One short, one tall. Okay, I'm going to use AOE for angle of elevation. Angle of elevation from the top of the short to the top of the tall is 20 degrees. And the angle of depression, AOD, from the top of the short to bottom of the tall is 35 degrees. Okay, and then I tell you the height of the small building is 50 meters. And my question to you is find the height of the tall building. So basically this is what you have. Let's just draw a nice little picture here. And that's like actually key. So you have a short building and you have a tall building. And here's your ground, which makes a nice perpendicular. Then let's read what we have here now. The angle of elevation from the top of a short building to the top of a tall is 20 degrees. So again, put your dotted line in here. So angle of elevation from the top of the small to the top of the tall is 20 degrees. Okay. The angle of depression from the top of the short, which is the left building, to the bottom of the tall, or I could say base if I wanted, is 35 degrees. So again, it's this way, and this is 35 degrees. Okay, and then the height of the small building is 50 meters. So I'm going to put 50 here, which just means this is 50 right here. Okay, and that's all you're given. So here's the deal, math fans. I really can't do anything with the 20 degrees right away. Okay, so what I want to do is I want to calculate something. I've got the 35 degrees and I got the 50. Well, what are you going to calculate? Certainly not going to calculate, you know, a height or this. It doesn't make any sense to calculate this hypotenuse here, right? Because that doesn't do any good. What actually does make sense is to calculate this value right here. Because once I calculate that, then I can go, I'm really looking for this, math fans. I'm looking for x, because once I have x, I add it to 50 and I get the height of the tall building. Okay? So if I'm looking for that red line, do you guys agree that I have 35 here and I have 50 here, 35 degrees? So what uses the 50 and the red line? Well, it's tangent again, okay, because it's not a hypotenuse. So I can say tangent of 35 degrees is opposite over adjacent, which is our, we're going to call this y. We'll call that y on there. Okay? And then let's cross multiply. So y tangent of 50, or 35, sorry, equals 50. Divide by tangent of 35. So y equals 50 over tangent of 35, which is 71.4. 71.4 meters. Okay, so now I have y, and I can go to the top triangle. And I can say, I've got y, and I have 20 degrees, and I need x. So again, there's no hypotenuse, so I'm using tangent again. So tangent of 20 degrees equals x over 71.4. Now I rounded that, and you're not going to round it. You're going to keep that in your calculator, because what I'm going to do here is if I multiply, I get x equals, cross multiply, so 71.4 tangent of 20. So truly what you're doing is, your last answer that you got was 71.4, blah, 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 blah. So you're just going to hit times tangent of 20. Because you never use a round answer for when you're doing anything here. And you get y equals, or x equals 26.0 meters. Okay, so that's pretty easy, 26 meters. And so then the total height, of course, is the short building plus that part on top. So let me move this down a little bit. So it's basically going to be 50 plus 26, which is 76 meters. Don't forget your units. Okay, so that's this whole height right here. Alright, so that's it, math fans, for angle of elevation, angle of depression. Relatively short lesson, and hopefully you guys are good to go with that. And again, don't forget to draw that horizontal line when you're doing an angle of elevation, especially angle of depression. Horizontal line, got to keep that in mind. Alright, that's it, math fans. Have an outstanding day. Adios. Goodbye.